Hi, welcome to Help You Math. Today we are going to use 3 different ways to solve this integration problem. Let's first look at the function side. Function we have is 3x minus 1 squared. Since our power is 2, this is not a very complicated function we have. First, I'm going to think about using the basic integration. In order to use basic integration, we think about the exponent we have. So here I have x to the nth power. So let's go over the formula we have. Respect to the x, if the n is not equals to -1, so we can solve this by our formula x to the n plus 1 over n plus 1 plus c. The question is, can we use the formula? In order to use this formula, our base must be x. Let's look at our function. Our function is 3x minus 1. This is not the same base. Therefore, we cannot use the formula right away. But we still want to use it. The idea right here is, how about we open the square so we can have each term to try to use the formula on the right side. In order to open the square, I can use the formula. That's give me 9x squared subtract 6x plus 1 dx. You can also do the multiplication 3x minus 1 times 3x minus 1. You will get the same result. So now we can give each term integration. Now we double check. So for my first term, I have 9 in front times x squared of course follow the formula. So the 9 I will be putting in front because it's a constant. I'm gonna do the same for the second term, which I put 6 in front. I have x inside. Last one is a constant 1. I will leave it first. Now we can start solving it. So first one, we have x squared, the power is 2. Then we can just follow the formula, give us x to the third over 3. Because 2 plus 1 is 3, so that's going to be x to the third. Then n plus 1 is 2 plus 1, that's going to be 3 again. So the second term I have 6. Follow the formula, that's going to be power is 1 right now, so that's going to be 1 plus 1 is 2. X squared over 2 plus a constant 1 will give us x because derivative of x is 1. Then our final answer will be right here, plus a c and end. Second method called U-substitution. I'm gonna write U-sub. Why we use U-substitution? Let's think about if I change the exponent, it's no longer to be 2. How about we have integration of 3x minus 1 to the 2020? That's going to be very hard for us to do it by using basic integration because I have to open it. That's too many terms we're going to have. So how about different numbers for the exponent we have? How about we have negative? If we can get the base to be something to any power, of course n is not -1, to respect to itself, u, we can still use the same formula we discussed, x to the nth power dx, which gonna give us x n plus 1 plus a c. So here we can follow the same because that's gonna be the variable, the same variable u right here. That's the same variable xx. So we can use this to be u n plus 1 plus c. So the same formula we have, but in order to do that, we need to use a different variable for our original function 3x minus 1 squared. So the U-substitution come out. Let's substitute it. So when we have exponential functions, it's very easy to think about our base is going to be our U. That's 3x minus 1. When we do U-substitution, every x will be changed to be U, and the dx will become du. So right now I have 3x minus 1 is u. I need to get my dx. So in order to get dx, we have to take derivative on both sides. So du will be 1 du. We didn't write down 1, but there's a 1 in front. So the 3x will be 3 dx. The constant will be 0 when you take derivative. Now we have du equals to 3 dx. In order to replace dx by du, we need to divide by 3 on both sides. So now we get dx equals to du over 3. Now let's do a substitution for our original function. Let's rewrite. That's going to be 3x minus 1 squared dx. Now it's changed to be u after the substitute. So we have the base. Here is my u as already defined. That's going to be u squared, and dx, which we solve right here, that's going to be du over 3. I can put the 1/3 in front. Now I have u squared du. That's the formula we are looking for to use. Now we have the same format. I can use the formula 1/3 u to the third, 2 plus 1, give me a 3. Follow the formula 2 plus 1, that's going to be 3 right here. Again, that's going to be plus a c. This is not your final answer because our function is starting with x. We have to do one more substitution back, the x to u. So that's going to be 1/3 3x minus 1 squared over 3 plus a c. This could be your final answer, depends on your professor what he wants if you need to simplify more. Third method is called U-substitution shortcut. Before we start, let's review about derivative problems we had before. So let's say I have x n plus 1 over n plus 1. Now we take a derivative of that respect to the x. So when I take a derivative right here, I just follow the power rule. So that's going to be n plus 1 in front. X will decrease by, exponent will decrease by 1. So that's going to be x to the nth power. So this cancels out. Result will be x to the nth power. Now we consider if we have u as a function of x, n plus 1 over n plus 1. Take a derivative. Now we follow the same formula on the top, so I'm gonna get u to the nth. However, remember, we have to follow the chain rule because it's not x anymore, it's a function of x. So we have to multiply the derivative of inside u, that's gonna be u prime. This is the key for us to solve integration problem right here. If I can have something like this, we are able to do the inverse to get u to the n plus 1 over n plus 1. Can we get u prime? Let's look at our problem. Our problem is integration 3x minus 1 squared dx. Our u is very clear. As the one we just done before, by u substitution, we're going to have our base to be 3x plus 1. Now I'm looking for the u prime, which is a 3. Derivative of 3x is 3, constant 1 is 0. So now I'm looking for 3, which is basically right here, u prime. Do I have it? I don't have it, right? Because let's look at our function we started, that's going to be 3x minus 1 squared dx. That's going to be our u. squared. I don't have it, so can we create the 3 by ourselves? If we multiply a 3 in front, now I create a u prime. This changes the function, but since 3 is a constant, I can divide it. I can put 1/3 in front. 3 times 1/3 is 1, so we didn't change the function. Now I prepared u prime for the integration function here. But remember, we are all doing by respect to the x, and the same right here. That's respect to the x when we take a derivative. Now we are able to get our result right away, which gonna be this one right here, which is follow the power rule. That's gonna be 3x minus 1 to the third, because that's gonna be 2 plus 1 over 2 plus 1, 3 plus c. That's it. Now you see the third method of integration by using U-substitution shortcut is very fast way to solve this problem. However, this doesn't mean the shortcut will solve all integration problems in the future. We're gonna see more examples in the future. Thank you.